Hello everyone. So today we're doing exercise 4.15, amplitude. So this question is quite simple. It gives us a position function x of t equals to c cosine omega t plus d sine omega t. And it's asking us to find the amplitude of this motion. And so how do you do this? Well, let's go back to the basics. We know that this is one form of expressing oscillation. What is the other form? The form that we usually learn first in school. Or the other form is just x of t equals to a cosine omega t minus phi, or plus phi. Or, you can switch out cosine with sine, just minus phi with plus phi. Doesn't really matter, but just to be clear, like this is one of the basics formula for oscillation. And so then we know that a here signifies amplitude. And so then let's try to rearrange this formula into this formula above. And then we'll be able to see how C and D relates to A, and then we will get a formula. So how can we do that? Well, if we look at this, let's try to expand this. We know the difference identity of cosine. And so then we know that expanding this, we get x of t equals to a cosine omega t cosine phi plus a sine omega t sine phi. And now you can see terms actually line up. So the question gave us c cosine omega t plus d sine omega t. Oh, and just to be clear, this phi signifies the phase shift or phase angle. That is how this cosine wave has shifted horizontally. But this isn't really important, but just to be clear about it. And so then what can we do? Well, we have this cosine term here and the sine term here, so we can actually start corresponding terms. So if we look at these terms, we have a and cosine phi corresponding to c, and a and sine phi corresponding to d. And so you can pause the video to see it more clearly, since like if you see here, you actually only have cosine and cosine here, so these terms must match, and you only have sine here and sine here, so these terms must match too. And so we have c equals to a cosine phi, d equals to a sine phi. And now we have a system of equations, of two equations. We're trying to find a. And so we just need to eliminate these phi terms. So how can we do that? Well, let's think about the identity. Sine squared phi plus cosine squared phi gives us 1. So how can we do that? Well, we can just square both sides of both equations. So this becomes c squared equals to a squared cosine squared phi, and d squared equals to a squared sine squared phi. And simply add these two equations together, we get c squared plus d squared equals to a squared sine squared phi plus cosine squared phi gives us 1, and so a squared equals to c squared plus d squared. And so then to get a, simply square root both sides, we get a equals to square root c squared plus d squared. And so this is actually a very useful formula, since when you are given a form of oscillation in this type of equation of something cosine plus something sine, you can always just square root and take their squares and their sum to get the amplitude. And so that is our answer to exercise 4.15. Thank you for watching.